So as promised in some of the last videos when we were talking about exponential properties, I said I would talk about a process called rationalization. And rationalization basically means if I have a number 1 divided by the square root of that number, a, I'm going to take that square root in the denominator and get rid of it. I want to get rid of it in the denominator so that I can approximate it better, because when you approximate it by hand, it's a pain to divide by a radical expression, and you just do not want to do it. Newton tried to do this, and he did it like to the 50th decimal place. And he finally started doing it to where he would put it in the top and put the expression and say, hey, this whole number goes into this how many times? Because it's a lot easier when your divisor, or the number in the denominator, is a whole number, or a number that's easy to manipulate, because that's the number that's going into that number. So what we like to do is we like to rationalize this. And basically, remember that anything times 1 is itself. So basically what I can do is I can rewrite this 1 into something better. Okay, so I've got 1 over the square root of a, and I'm going to multiply it to get rid of the radical expression in the bottom as the square root of a divided by the square root of a. Now I'm not changing the scalar quantity of it, I'm just rewriting the expression. So I'm not changing the value of 1 over the square root of a. I'm not changing this value at all. It's still going to be 1 over square root of a. But instead now it's going to be the square root of a divided by the square root of a squared. If you simplify it, you're going to get the square root of a divided by a. And so essentially what happens is you basically take out the radical expression in the denominator and rewrite it in the form of this right here. And this is the process of rationalization. So let's do an example where we have 1 over square root of 2. Okay? If I rewrite this as 1 over square root of 2, I'm going to multiply by the square root of 2 over the square root of 2, which is basically 1. And then you're going to get, hey, 1 times the square root of 2 over the square root of 2 squared. Now, basically what happens is, if we remember this property, if I have the a to the nth root, and I take the nth root of a to the n power, which is a to the n power, I'm going to get a. So a to the nth root, and I want to cancel, or a to the nth power, I want to cancel it out. I'm getting a little dyslexic here. I'm going to cancel it out by taking the nth root, and I'll do it in red. I'll do the nth root of a to the n, and it'll cancel it out. And I'll do that one in blue right there. And the red and blue values will cancel out, thereby leaving me with a. And that's what happens right there. I'm going to get this to cancel with this. Okay, so I'm going to get the square root of 2, because anything times 1 is itself, divided by 2. Let's do another example. 1 over the square root of 3. Or let's not do 1. Let's do 2. 2 divided by square root of 3. Well, multiply by the square root of 3 over the square root of 3. It's still 1. So you're going to get 2 times square root of 3 divided by the square root of 3 squared. Remember that the square root of 3 and the square component cancel, and so you're left with 2 square roots of 3 divided by 3. And that's it. That is rationalization in a nutshell. So basically, hopefully this helps you out. There are some other processes where you do conjugation, stuff like that, but we'll talk about that in a later video.